potential plus quakes. But guys, let's look at CERN a minute. They're running hot and heavy. Now, I just want to show you that they're at their 13 TeV collision point. And when they're talking about running this many collisions, they're talking about hitting degrees of, as far as friction and collision point temperature increases of 40 trillion degrees and creating their own magnetic field. I'm going to go back to a video as we look at this. Notice that 2,076 bunches of protons hitting each chamber at 6.5 TeV, giving you 13. Guys, notice it's proton to proton, and it's almost going into alchemy when they're going to go into later in the fall, proton to lead collisions. But I want to pause here and show you a couple things. This is an older video that was done by CERN, but it explains very well what they're trying to do, and that's create a quark gluon plasma. And it's really taking time backwards into the time just before, I think, God locked the fallen angels away. And that's what they're trying to break free from. But check this out, guys. I got one other short video coming up about Hillary and Warren Buffett. So heads up, be safe.
In 2005, physicists at the Relativistic Heavy Ion Collider, RHIC, announced the discovery of a perfect liquid of quarks and gluons. Since then, scientists have been taking a closer look at this hot soup. One group has been looking back in time to the earliest point in the collisions to measure the temperature by looking at the color of light emitted. Think of looking at a glowing iron rod. As the temperature gets hotter, the glow moves from red to yellow and then white. At RHIC, measurements beyond the visible spectrum reveal that the temperature reaches 4 trillion degrees, hot enough to free quarks and gluons from their individual protons and neutrons. Another group of scientists has been investigating a separation of charges observed at RHIC. Because the colliding ions are themselves moving charges, they induce a magnetic field. This magnetic field and vortices formed within the quark-gluon matter lead positively charged quarks to move preferentially in one direction and negative ones in the other due to the existence of different symmetry properties within these vortices. This asymmetry at RHIC may help scientists understand a similar violation of symmetry in the early universe that resulted in the predominance of matter over antimatter in our world.